Actually, there's actually 3 sections about linear, and we didn't even do the second one. And I'll mention here, but it's because we're going to do it later. It kind of fits in 2 different places, and it's covered for more of what we need it about in a later chapter. But, if we understand y equals mx plus b, which we do, right? That's the equation of a line. What if there was no b? What kind of line would you have if b was 0? It means the y-intercept is what? It's 0, so it's going to the origin. Okay, that is the particular kind of linear equation called a direct variation. And if I double x, I double y. If I cut x in half, it cuts y in half, as long as the slope stays the same. And we're going to just save it for later. In the end, it's just one particular kind of straight line, and I think we understand the straight line's okay. So then the last section, 2-3, was all about slope-intercept, and then we do 2 other forms of equations of straight lines here. And the first one, this objective here, is about one of them. And then this one is about the other, basically. So remember, last time we said linear equations can be written in 3 forms, and we dealt with slope-intercept last time, and then this time we do the other 2, point slope and standard. The point slope especially is very useful, okay? It's very useful. I use it every once in a while, like doing grading. I'll explain it later. Standard form can be useful. When we present it, I'll show you what it's used for mostly, but they each have their own purposes. You remember the slope-intercept form is most useful because it's already solved for y. It's in the function notation when you start with it. And if you want to graph it in the calculator, right, you got a y equals button on the calculator, that's the one you've got to use, right, because it's solved for y. Okay. Kara, are you okay? Anybody? Slow me down if I go too fast. Right, that's the point slope form. As the name implies, what do you need to use the point slope form of a line? A point and the slope, right? As long as you've got those 2 things, one point and the slope, then you can use the point slope form of the line. Right, so the point in this equation is the x1, y1, right? That's the point part of it. And the m, as always, is the slope. Sometimes this question comes up, what are the x and the y? Not with the sub 1, but just the plain old x and y. What are those? They're variables, right? They're variables. Remember, the equation will have an x and a y in it in most cases. So you need to have an x and a y that can take on all the different values. So those in the end will not be filled in, but the rest of the stuff's going to get filled in as we do this stuff. Sure, if I was going to say something about that. Okay. So the first couple examples, pretty easy. If they give you the point and one slope, then you should be able to use that, right? And here's this going to be our x1, y1, and here's going to be the m. So using this equation, y minus y1 equals m times x minus x1. Right. We're going to substitute. We're going to put the 7 is going to go here. The -1 is going to go here. And the 3 is going to go here. So substitute. Y minus -1 equals -3x minus 7. Now, in this example and in the homework problems that are like this example, they say leave it in point slope form. They do not say solve for y, put it in slope intercept form. But they would do one little bit of simplifying here. The minus and negative, you should change to a plus. Right? That should be y plus 1. Right. Sometimes I see, like when we're doing problems like this, let's say I said solve for y, put it in slope intercept form. You know, that at a certain point you've got to like get this to the other side. And you don't simplify the minus and negative. You try to do some kind of minus a positive or whatever, and it doesn't work out. You get the wrong sign. It's better to turn the minus and negative into a plus before you start adding things side to side. Then it's pretty clear. What are you going to do? Subtract 1. Okay. Too easy. So try to do the same thing with this. Line passes through the point negative 5, 2, has a slope of 3/5. What is the equation of the line? And by equation, we mean point slope. Right. So do it yourself. Too easy, right? Yep. Y minus 2, x plus 5. Y minus 2, x plus 5. No, that's not plus, that's a minus. Right? It's y minus the y1, and the y1 is positive. Did you mean that to be a... Oh. Y minus 2, x plus 5. Y minus 2, x plus 5. Done. That's all you have to do. I didn't ask you to solve it. All right, so this is y minus 2 equals 3/5 x minus negative 5, which is x plus 5. What if you were asked to graph it? Solve for y and then use slope intercept? Do you have to do that? If you actually already know one point in the slope, I mean, you could still graph it right away. Just graph this point, negative 5, 2, 1, 2, 3, 4, 5, and up 2, sorry, negative 5, 2, and then use the slope of 3/5, which will go up 3 over 5. There's your second point. So you don't really have to put it in the slope intercept to graph it. Just use that point in the slope. In the end, I mean, that's all the slope intercept is. It's just one particular point. It's the y-intercept, and use the slope from there. So you can graph this just as is. And most of the time, you don't get a slope and a point to plug into these things. You get 2 points. Okay. And what do you think the strategy will be in order to use the point slope form? If the point slope form asks for 1 point in the slope, but we've got 2 points and no slope, find the slope first, right? You can find the slope with these two, and then you'll have the slope, and you'll actually have 2 points, and you only need 1. Now, I use this fairly frequently as a teacher in ways that it's not because I'm a math teacher. Any teacher might have to do the same thing. But the example that I'll give you, and you guys are pretty young. Some of you are taking like AP Human Geography or something like that. You know what the scale of the AP test, you know, what are the grades you might get on the AP test? 1, 2, 3, 4, 5, right? When I was teaching AP statistics, in AP statistics, to get a 5, you know what the percent correct you needed to get on the test? 63%. That was the minimum 5. 49% was the minimum B. 37% was the minimum C. And I forget what it was about 29%, or sorry, 49% was the minimum 4, 37% was the minimum 3, 29% I think was the minimum 2, and below 29% was a 1, right? But the thing is, we did mock exams and things like that were scored that way, but somehow I've got to turn those grades into our grades, which are 90, 80, 70, 64. So that I did this, right? For example, let's say if the AP scale, like for the 5 goes from 63 to 100. It may be different for AP Human Geography, but this is what it was for AP Stats, right? The 4 went from 49 to 63. The 3 went from 37 to 49. A 2 went from 29 to 37. And then the 1 was below that. I got to turn that into A, B, C, D, right? So I would say, let's say, and I'd have to have a different linear conversion for each grade, okay? But let's just say for the B. Let's say I wanted the B to be match up with a 4. Then I would say if a kid got a 49 on the AP mock test I gave them, they should get an 80, the minimum B in my grading. So that's a point. 49, 80, right? And at the top of the curve, if they got a 63, then I'd want that to correspond to a 90. So there's another point. And then I would do exactly what we're about to do here to come up with an equation. And I would solve it for y, because then I could put it in a calculator or put it in an Excel spreadsheet and do all these conversions. You know, so the fact that I'm a math teacher maybe makes it a little easier, but anybody might have the same need to figure out a way to convert from one thing to another. So let's see. We've already said the strategy here is going to be calculate the slope first and then use that to come up with the equation. So the slope in this case will be y2 minus y1, 7 minus 0 over 0 minus negative 5, which is 7/5. Okay, now that we have the slope, how do we use the point slope form of a line? Well, definitely we're going to plug in the 7/5, but we got 2 points. Which point do you plug in? Doesn't matter, right? In the end, it doesn't matter. So let me use 0, 7, because there's no negative in there, you know, because since it doesn't matter, I might as well. So I'll use y minus 7 equals 7/5 x minus 0. All right, well, what if I'd have used the other one? It would have looked different, right? What if I did this? I said y minus 0 equals 7/5 x plus 5. Depending on which point you use, you're going to get a different answer. And in the book, your homework problems say leave it in the point slope form, and they don't tell you which point to use. I don't know whether they're going to give you both answers in the back of the book. They may give you the one that used the other point, so your answer won't look the same. But that's the difference. Now, if you solve for y, it'll be the same. Right? It looks different in this form of a line, but it doesn't look different when you solve for y. Right? This one is y minus 7 equals 7/5 x minus 0, so that's gone, and then add 7. So that's y equals 7/5 x plus 7. Okay, over here we have y equals, the minus 0 goes away, 7/5 x, and then the 7/5 times 5 plus 7, right? So these are the same. These are the same once you solve for y, but they will look different depending on the point you use in point slope form. Now, if I did this, just to show you, right, I would calculate my m. Right, m equals 90 minus 80 over 63 minus 49, which is 10 over 14, which is 5 over 7. And then I would use one of those 2 points y minus 80 equals 5/7 x minus 49. And then I can solve that for y. That'll be y minus 80 equals 5/7 x. And what's 5/7 times 49? I mean, the 7 divides into 49, right? 7 into 49 goes 7 times. So 5 times 7, that's minus 35. And then I add 80 to both sides. Y equals 5/7 x plus 45. So that's something I can use for all my grades. When I get the scales on the AP scale, then I plug them into that, usually with the Excel spreadsheet, and then I just have a table I can read it from. You know, if, for example, just to take one, this would only work for the scores that came back between 49 and 63. I have a different equation for all the different grades, AP grades. But let's say I got a 56, because 56 is divisible by 7, right? So if you got a 56 on your AP test, what would be your score for your grade? 56 over 7 is 8. 5 times 8 is 40. 40 plus 45, 85. So you get credit for middle B for a 56. Yeah. No, in the homework it says just use point slope form. So just you pick a point. My guess is they're probably using the first. If there was 2 points, they're probably using the first. But don't be surprised if their answer is a little different just because of that one thing. Okay, do the same thing. Given 2 points, write your equation in point slope form. And just so we all get the same thing, let's use the first point as x1, y1. So calculate the slope and then plug in for the slope x1, y1. What do you get? Good job. Good job. Getting it? Getting it? Where's your M? You got to fill in for the slope. First, calculate the slope. What's that? No, you don't. Just use the points. y2 minus y1 over x2 minus x1. Right? You got to know how to do that, Jessica. And you have solved it. Good job. Good job. You doing these things?
Yes.
Where?
I just have to.
So, what's that? Mine. You can do a retest? Okay, well, I think it'd pay for you to actually try here. Because from what we've seen, you probably don't know the stuff we learned before that well. Okay. So what was the slope? It was 3, right? So M is 8 minus 2 over 5 minus 3 equals 6 over 2, which is 3. And you definitely should be simplifying 6 over 2 to 3. And then if we use that point, we have y minus 2 equals 3, x minus 3. Right? Easy. Like I said, practical. And you might, the thing about, we learned about a lot of kind of functions in this class because the relationship between 2 variables is not always linear, and maybe not very often it's linear. But it's not a bad approximation. I mean, sometimes just go ahead and see what the linear equation would be between the 2 points. I mean, how much different could it be? Sometimes it's pretty darn close. Okay, the other form of a line that we learn is called standard form. And standard form is this right here. AX plus BY equals C, where A, capital B, capital C are all real numbers. Right? What's particular about this form is the X term and the Y term are on the left, the constant is on the right. X and Y terms on the left. You know, you always write the X term first. Now, for our purposes, what's useful about this form of the equation of a line is that it makes it very easy to graph by finding the x-intercept and the y-intercept. You know, other than that, I mean, there are not a lot of times that we deal with equations in that form because it's not solved for y, right? You know, we really want the function form of an equation if we can. But, you know, if you remember in your Algebra 1 days doing systems of equations, do you remember what's a system? More than one, right? If you have two equations and two variables, then their solution is wherever they intersect. Do you remember that part of it? And the way that you solved for that intersection point was either substitution or elimination. And usually for the elimination method, they were in this form when you started, with the x terms lined up and the y terms lined up. Okay. We used to have a chapter in this course where we did systems. And at the end, they had this kind of word problem-y kind of thing called linear programming. And in linear programming, it was very handy to be able to graph those equations, which were always in the standard form, just by putting on the x-intercept, the y-intercept, draw a line. It was very handy to know that. But we don't even do that anymore. But still, this is part of it, and knowing what we mean by x-intercepts and y-intercepts is an important part of the class. Okay, so what do we mean by the x-intercept? Yeah, maybe it's better named the x-axis intercept, right? It's where it is across this line. And the y-intercept is the y-axis intercept. Where does it cross that line? Okay, the key to finding these is that you know on the x-axis, because it's vertically right in the middle, it's not above, it's not below, everywhere on the x-axis, y equals 0. Right? And to find the y-intercept, we take advantage of the fact that everywhere on the y-axis, x equals 0, because it's not to the left and it's not to the right. So these statements at the bottom here, I mean, this is how we find intercepts for all the functions that we do. For this year, next year, calculus, when it says find intercepts, that's what we mean, right? So I'll put a red star next to that. That's important. You know, I read a lot of education stuff. And I remember there was, I was interested in a subject, and there was a blog that was written about why do we teach Algebra 1 and then Geometry and then Algebra 2 instead of doing Algebra 1 and then Algebra 2, right? And, you know, that comes up, it's come up 2 or 3 times with administrators so far this year. So I did a little bit of reading. And, you know, truthfully, there's an appropriate level of math you need for geometry, which is not near what we learn in this class. We learn way more than you need for geometry, right? So making geometry go after Algebra 2, I mean, it's not because you need more math to do geometry. But the people that commented on the blog, they said, there was a lot of them that said, you know, in our school system, we did change it. We went to Algebra 1, Algebra 2, and geometry. And almost everyone said they changed it back. After a while, they realized they didn't like it, and they changed it back. Son? Because you need some algebra to do geometry. right? There was, if you remember what you did in geometry last year, whenever it was, there was a little bit of algebra that comes up in that. So yeah, you do need algebra 1 before geometry. The question was whether to put geometry at the end. But this one guy who wrote it, I always remembered what he wrote on that blog. He said, when students don't do well in algebra 2, it's because they've generally learned their math and their algebra to that point as a bunch of disconnected facts and procedures, right? You're not tying all this stuff together and see where things fit. These are the kind of things that you don't want to say for, okay, I did linear equations, and for linear equations, we learned that to find the x-intercept, you do this, you do the y-intercept, you do that. And then you learn new procedures when we do quadratics. No, it's always the same, right? We learn this principle, and it'll apply all the time. And even what we do in the next lesson, which is about how do you shift basic patterns, graphs of functions around by adding and subtracting and putting negatives in front and all that. It works the same for every function. It's kind of like conjugating a verb in a foreign language, right? Once you know the basic verb pattern, you can conjugate anything. Make up a word that's got that ending. You should be able to go all automatically and do it. You don't want to learn everything as just another fact to be memorized, like you're memorizing the digits of pi, that have no pattern to them at all. That's hard to memorize. Instead, you want to fit things together in ways that make sense. And these two will come up over and over again. You want to try to make sense of it so it makes sense for you later. And you're not learning a new thing. You're saying, oh, I'll just do that thing again. Okay, so what are the intercepts of? And we've got an equation which is in the standard form. Right? And if you remember from the last slide, what did we say about how we're going to find the x-intercepts? Substitute y equals 0, right? So watch how this works, right? 2x minus 4 times 0 equals 8. But 4 times 0 is 0. So really all you've got is 2x equals 8. And that's a pretty simple solve, right? X equals 4. This is what I usually do for this. And this is really the way that we use the standard form and why it's so easy to do. Watch this. Let's see if I got the circle. I got the circle. Generally, when you want to find the x-intercept, you know that the y term is going to go away. So you just cover up the y term and then solve what's left. 2x equals 8, x equals 4. Right? On your page, since you got it on your paper, just use your finger. Cover up one term, solve. Cover up the other term, solve. There's your intercepts. It takes seconds. Right? What is going to be the y-intercept here? Cover up the x term. Negative 4y equals 8, so y equals negative 2. So with those 2 points, x equals 4 and y equals negative 2, I only need 2 points to graph the line. So find the intercepts. If it's in standard form, just make it quick. Find those 2. Cover up one, cover up the other, plot your 2 points, draw a line. Like say, if I was you, because you got paper, I'd just be putting my finger over one, put my finger over the other, solve. Plot the 2 points, draw a line. Now, some of you, you're going to get like a standard form to graph, and you're going to say, well, I'm just going to solve it for y, and then I'll graph it like a slope-intercept, which is fine if you do everything right. But if you make some mistake along the way, then you might have wished that you just plotted with the intercepts. So try that one. 3x plus 5y equals 15. sketch it? Or is, you're not doing it? On strike? Don't get it? Don't get it?
I did it in my head.
Oh, okay. I'll grade it in your head. How's that? I think you got those switched around. If y is 3, then that's the 3. All right, that's the y-axis. 1, 2. What number is that?
Oh, what's the axis?
You missed a point. Are those axes perpendicular? Do you draw your axes at a tilt? That was a 3. What'd you write 2? Slappy. Did you get it? Okay, that's not a point. Those are intercepts. Yeah, you got a graph now. What did you do there? So 1 minus 3. That's not 3. That's negative 3. Right? That's right. Make sure to show enough little tick marks so you can see what it is. Let's see. When you cover up the y, you get 3x equals 15, so x equals 5. You switched them around. Right? And you switched them for no reason. And you're solving for y instead of using the intercepts. And you're wrong. Okay. Again, you made a mistake here. If x equals 5, that means the 5 is there, the 3 is there. Okay? So again, if you, okay, watch, you cover up the y, solve for x. 3x equals 15, so x equals 5. X equals 5. Now, what point is that? Like, what are the coordinates of the x-intercept? It's 5, 0, right? And then cover up the other one, right? 5y equals 15, so y equals 3. So y equals 3, that means 0, 3, right? It's not the point 5, 3. That is not a point on our graph, right? 5, 3 is not a point on our graph. 5, 0 and 0, 3 are points. So 5, 0 would be here. 0, 3 would be here. Draw a line. And that's pretty close. Okay. So again, the whole reason that we learn standard form is for this method of graphing. That's why we learn it. Okay. Cover up one, cover up the other. Plot your intercepts, graph. Now, there's one last thing for you guys, because you're the higher class. I didn't teach the other class. I used to be in all the time, but things change. If you have two lines and they're parallel, what does it mean to be parallel? It means that the lines don't intersect, right? Which means they have the same slope. It means that they're going up and over exactly the same. So if they start with a distance between them, they're going to always have that same distance between them, right? Parallel lines have the same slope. If I say like one of them has a slope of m1 and the other has a slope of m2, then the slope is, they're equal. m1 equals m2. Right? Parallel lines have the same slope. What does it mean for two lines to be perpendicular? They intersect at 90-degree angles, right? Right angles, 90-degree angles. That's what it means that two lines are perpendicular. Okay, right angles right there. So if you look at the two lines that we've got there, the red line, is the red line have a positive slope or a negative slope? positive. It's going up from left to right. Does the blue line have a positive or a negative slope? So always going to be the case, right? If they're perpendicular, one will be positive, one will be negative. So clearly one slope is going to be, they're going to have different signs. So here's the M1 equals 1 negative 1 over M2, which if you looked at it, you probably don't quite see what they're getting at there. But look at it like this. If the M1 is 2/3, that means the M2 is negative 3/2. Perpendicular slopes are opposite signs, flip the fraction. That's what they're saying with this negative 1 over M2. Okay. What about if it was negative 4/7 is the M1? What is the M2? Matt? You were saying it? It's opposite sign, which makes it, and you flip the fraction, so positive 7/4. Okay, if the M1 is 2, what's the perpendicular slope? Negative, John? No, this is 2 over 1. Negative 1/2, right? The M2 would be negative 1/2, right? Flip, this is 2 over 1, flip the fraction. You know, again, same thing. What if this is negative 1/3 for the M1, then the M2 is positive 3. Yeah. Right, so in order to find the perpendicular slope, you opposite sign, flip the fraction. Parallel, same. Perpendicular, opposite sign, flip the fraction. Here, they also say here, M1 and M2 are negative reciprocals of each other, which is what I'm saying. You okay, Kara? Kareem? That's for perpendicular. Okay. So we're going to do 2 problems. The first one, I didn't mark these out, but let's cover that up. Okay, we want to find the equation of a line that is in slope-intercept form, which is parallel to this line, and it goes through this point. Okay, what are they trying to tell us by telling us that our line is parallel to this line? It's the same slope, right? So it's kind of like indirectly telling you the slope. Our very first example was what? Here's the slope, here's the point, find the equation of the line. That's what we're going to do. It's just that we're going to have to take a step to find the slope because we don't know yet. How will we find the slope of this line, which is not in slope-intercept form? Solve for y, and then we'll tell the slope. Okay. So let's do that. 4x plus 2y equals 7. All right, 2y equals negative 4x plus 7. Y equals negative 4 over 2x plus 7 over 2. So y equals negative 2x plus 7/2. Okay, so what is the slope of this line? Negative 2, right? This line has a slope of negative 2. Okay, what is the slope of our line? Negative 2 because they're parallel. They're the same slope. So now we're being asked the question to write the equation of the line if m is negative 2 and it goes through the point 4, negative 2. Right? How did we do that in the very first example? Which form of the equation do you use when you know one point and the slope? Point slope. Again, by the name, you know which one to use. So we're going to use this. Y minus negative 2 will be y plus 2. Negative 2 times x minus 4. And it says put it in slope-intercept form, and that means solve for y. Okay, how am I going to simplify the right? Properties, right? Distributive. Everybody knows distributive. You can't remember commutative or inverse or identity or any of that, but you can remember. Right? So distribute, make sure you switch the sign. Negative 2 times negative 4 is positive 8. Okay, one last step. Minus 2. So y equals negative 2x plus 6. Right, so again, them telling you that your line is parallel or perpendicular is just another way of telling you the slope. You're just going to have to like do a little figuring what that's going to be. In this one, it was easier because parallel, it's just the same. You don't really have to do anything with it. You just had to find the slope of the first line. Okay, let's do this. Now we're going to do this one. Right? Find the equation, slope-intercept form of a line which is perpendicular to this line and going through this point. Okay, well, do we have to solve this line to know the slope? No, it's already in slope-intercept form. So you could tell right away this line has a slope of 2/3, right? 2/3. What is the slope of a perpendicular line to this? Negative 3/2, right? If this is the slope of this line, 2/3, then our slope is negative reciprocal, opposite sign, flip the fraction. So our m is negative 3/2. And our point is 0, 6. Okay, do we need to use point slope form for this? We got 1 point, we got the slope. No y. Okay, which means that point is what? When x is 0, that point is the y-intercept. We've actually got the slope and the y-intercept, and that's actually the form we want. We want slope-intercept. There's no point to put it in point slope and solve for y. We'll just go right to y equals mx plus b, because that's exactly what we know. Right? So we can go y equals negative 3/2 x plus 6. Right? If you went to the point slope, it would be y minus 6 equals negative 3/2 x minus 0, add 6, y equals negative 3/2 x plus 6. Right? You'd get to the same place, but if you recognize that they just gave you the y-intercept, then it's actually a little easier than that. So again, when you get these problems, I think there's 2 at the end of the homework. They're the hard ones, right? You just have to say to yourself, what are they trying to tell me when they're using this parallel and perpendicular stuff? What are they ultimately giving you a clue to know? The slope. They're just trying to tell you the slope a little indirectly. That's it. So when you see the parallel and perpendicular, just say to yourself, all right, parallel means the same, perpendicular means switch sign, flip the fraction. And then do what we did on example 1. Everybody all caught up and everything? That's the end. All right, so write the equation of a line given the slope and a point on the line. That was the point slope form. And then again, this, probably most informative for the intercepts. There's other parts of it that we'll do at other times. That's the homework, but I'm missing something there. Okay, add those 2 on the end because they're the perpendicular parallel stuff.